In this video, we'll generate the Chebyshev First Kind Polynomials dataset, the trendline equation, the Chebyshev First Kind Polynomials, and we'll draw the trend line on this chart. Our values for n will be from 1 to 10, and our value for x will be from -1 to +1. So the Chebyshev first kind polynomial is defined as a times 1 minus x to the power k, where the value of k is equal to 0 to n, and a, the coefficient, will be n times -2 to the power k times factorial n plus k minus 1 all over factorial n minus k factorial 2k. So we begin with the values of n. So data validation from the lists. We'll copy these values, paste here. Here you have the values for n. And our values for k will be from 0 to n. So this is equal to sequence n plus 1 column starting from 0 incremented by 1. So if our n equals 1, then that's 0, 1. N equals 2, our k is 0, 1, 2. N equals 3, our k is 0, 1, 2, 3. Now we'll continue with the Taylor Maclaurin series sum for the Chebyshev first kind polynomial. This is equal to array formula, series sum 1 minus x raised to the power k, where k starts from 0 incremented by 1, and the coefficient will be this h. So here we have the trendline equation, which is also known as the Chebyshev first kind polynomials up to the degree 10, and our trend line. Next, we continue with the coefficients. Coefficient A, starting with the numerator. So it is n times -2 to the power k times factorial n minus k, n plus k minus 1. So that's the numerator. If this cell is empty, this should be 0. So we have to correct that. So if k is empty, this should be 0. Otherwise, calculate. Now this is now fixed. Now we continue with the denominator. The denominator has two parts. So we have divided by n minus k. So factorial n minus k. N minus k. But it's a product. There's another factorial times another factorial 2k. 2 times k. So here we have the On this side we have the series, the Chebyshev first kind polynomials, where in the form of trend line equation to the 10th degree, and here's the trend line. So we start from 0, or for 1. So at n equals 1, the our y, or the Chebyshev first kind polynomial, will be y equals x, 1x. N equals 2, the first kind, our Chebyshev first kind polynomial, y equals minus 1 plus 2x squared. The rest are 0. At n equals 3, you have minus 3, y equals minus 3x plus 4x cubed, and that's it. At n equals 4, our y equals negative 8x squared plus 8x to the 4th, and that's it. So 1 minus 8x squared plus 8x to the 4th. At n equals 5, y equals 5x minus 20x cubed plus 16x to the 5th. That's it. At x equals 6, y equals negative 1 plus 18x squared minus 48x to the 4th plus 32x to the 6th. That's it. Y equals 7, or y equals minus 7x plus 56x cubed minus 112x to the 5th plus 64x to the 7th. And that's it. And 8, y equals 1 plus 9 minus 3, 1 minus 32x squared plus 160x to the 4th minus 256x to the 6th plus 128x to the 8th. And if n equals 9, or y equals 9x minus 120x cubed plus 432x to the 5th minus 576x to the 7th plus 256x to the 9th. And at n equals 10, y equals negative 1 plus 50x squared minus 400x to the 4th plus 1120x to the 6th minus 1280x to the 8th plus 512x to the 10th. So this completes the use of sequence, array formula, series sum to generate the Chebyshev first kind polynomials.